So this is a project that we started in February of 2009, and we started with a competition to win this project. This is for the Los Angeles Community College District. It's at their Harbour College campus in Long Beach, California. It's about 66,000 total square feet, 3 stories, 23,000 square feet of which is laboratory space, science labs, chemistry labs, physics labs. Not all of the labs needed fume hoods. Some of them were just computer labs and the like. The rest of the space was split between lecture classrooms, offices, collaboration spaces. And sort of the unique thing about this is we had to go into a competition to win the project with a contractor and several other different sorts. Our Los Angeles office for HGA is architecture only, and we did not do the mechanical engineering nor the electrical engineering for this project, but we did provide all of the energy modeling support and sustainability support for the project out of our Minneapolis office. It's currently under construction, and as you can see on the screen, it's scheduled for completion and opening in 2012. There are some goals for the project going in, even during the design phase, was to make this a net zero energy building, which with 1/3 of the space being lab, presented its own challenges. However, we were aware going in as well that the project would have access to the PV farm, the photovoltaic farm on campus. So a lot of that power we're going to be able to claim, or we think we're going to be able to claim as dedicated for this building off of the PV grid. BIM was required by the owner. We ended up using a mixture of several different types of tools. We used Revit, started in Revit 2009, and we used Google SketchUp version 7 along with the VE and a couple of other Energy Pro, for example, for Title 24 compliance. So, like I said, we had 2 distinct phases. The competition phase, we were shortlisted out of 36 firms down to 3 teams that were then interacted with the client throughout a 3-month process. We were awarded the project out of that competition phase, which we used the VE for doing a lot of the pre-design studies. And then we carried all of the information through from the competition phase through to the design phase. It worked really well to carry everything over that we had started in the competition phase and into the design phase. And we're currently, I guess you could say, in the documentation phase of getting everything complete to submit to USGBC for the LEED Platinum plaque. So we started off with using in the competition phase just some really high-level tools. The Sustainability VE-Toolkit in the VE, for example, was able to output some useful charts and graphs. These are a couple that you are probably familiar with if you've seen your Sustainability Toolkit. We did a lot of different massing studies once we had a handle on what the climate was. We looked at a lot of different climate files. We ended up selecting the Daughtry Field climate file because of its proximity to campus, and we confirmed with local representatives that the climate there, or the weather, the data in that weather file closely matched the site weather, which was, like I said, about 6 miles from the weather station. So we also drilled a little bit deeper, and I used the VE to output all of the data, and then I just used Excel to come up with some very simple graphs. We wanted to look at things like natural ventilation, daylighting, and the opportunity to look at using thermal mass for this project as well, to do some nighttime cooling or storage with a thermal mass. Ended up, as we went through this process, because of budget constraints, we ended up not getting everything that we needed, but we settled up with what we think was the optimal solution. This is the windrows, again, out of using the Vista Pro Beta module. And you can see the predominant winds are out of the northwest, west, and south. And what we found was actually the east winds that you see, which are pretty weak, are actually warm air winds. They're coming from inland. So they're usually hot winds. So this solution, that the building in the center, is the solution for the building. But I'm going to back up a little bit and go through what we went through to get to this solution for the shape of the building. This is a ranking system that we use here, if you're familiar at all with lean product delivery or anything like that Toyota sort of pioneered. We've sort of adapted that to our work process here at HGA. And along the left, you can see 12 different schemes. different orientations of the building, donuts, single-loaded, double-loaded building configurations, different story heights. And we went through and we ranked them on sustainability, integration with what the campus needed for the master plan, collaboration for the teaching environment, basically all of the real high-level thinking that the client required. And as you can see, we settled with solution number 12, which is what you saw in the previous image as far as the site plan goes, where we had separate buildings. And the reason that we ended up with this type of a shape of the building was to enable for the building to sort of shield itself from the hot winds while allowing the maximum amount of natural ventilation for the spaces that weren't laboratory spaces. These are what we started off with looking at in the competition phase as different, sort of a summary of different sustainability ideas that we wanted to look at for this project. Vertical and horizontal louvers for shading, light shelves, high-performance enveloping glazing, photovoltaics along the south. That whole section along the south ended up being photovoltaics, wind turbines, which ended up, for two reasons, getting dropped from the project. I'll touch on that in a little bit. Buried mass to reduce sun exposure, et cetera. A lot of desert concepts as well, just because of the dry nature. Although it isn't really hot in this climate, it's a very temperate climate. But we did want to minimize solar exposure because in Southern California, if you're not aware, you get sun like 95% of the year. This is how we sort of programmed each of the spaces. The green areas represent laboratory spaces that are currently not with fume hoods, but they are actually like there's a solar lab in there and there's computer laboratories in there. But the future plans, there are ducts in place and piping in place for them to connect in the future to convert those spaces into chemistry labs or physics labs. So for now, they have naturally ventilated openings, but they will be converted at some point or could be converted at some point. The gray areas are support areas, your toilet rooms, your mechanical spaces, those types of spaces. The orange is classroom areas, lecture halls, and then the blue areas are the actual areas for that where the laboratory building is, or your chemistry labs, physics labs are where the fume hoods are. So again, we put all of those in that core to sort of, that was the place where we didn't really need to worry about natural ventilation because we had lab spaces and we couldn't use natural ventilation. We had to maintain a very tight temperature tolerance between 72 and 74 degrees Fahrenheit and a relative humidity of 40 and 60%, 24/7, 365 days a week. Obviously, you can't do that with a natural ventilation strategy. So we intentionally put those spaces in that part of the building. We were also concerned with the L shape of this building and making sure that we could leave some open areas to get air to pass through from one side of the building to the next. In other words, we didn't want to shield the areas over here on the north part of the building by using the south part and these solar and these PV and shading elements here. So we studied this in some detail with some simple CFD models and indeed with macroflow, and we found that we felt comfortable with what the modeling suggests that we could get for natural ventilation flow. We did also include the site. This year is actually the campus boiler plant that serves the entire campus. It's far smaller in Southern California than it would be here in Minneapolis. Some of the solar shading studies, we wanted to take a look at what was the best location for putting PV on the building. We knew that the roof is obviously a good place because you're not going to be shading the PV panels from themselves or from other surrounding areas. The site, there are no buildings nearby that are over 4 stories tall, so we weren't concerned with anything. If you're familiar with Southern California, I always say it's analogous to a giant strip mall, but there aren't any tall buildings that we were concerned with. What we were concerned with was if we stack all of these shading elements like we have here, how often do they shade each other on the south? Because the peak PV generation time is in the summer months, June, July, August, and we wanted to make sure that we weren't blocking the sun during the peak PV times. Well, it turns out that they do block the sun for basically 1 month of the year in June, and only from about 11:30 to 1:30 during the 11:30 to 12:30, I should say, during the day. So while there was some shading that occurred for the vast majority of the time, they weren't being shaded. So we ended up keeping the PV on the entire on the entire south facade. We also wanted to study the impacts of daylighting, and we used, in the competition phase, we used the simpler radiosity diagram from FluxDL to get very simple false color images that communicated what the light levels might be to the owner and how effective our glazing strategies were working. You can see the same room with two different options as far as windows are concerned. Window shapes, putting some sort of shading element in the one. And we came up with, well, it was a balance between blocking the sun and allowing the natural light to come in. The PV and the wind, the PV in Southern California, like I said, something like 90 or 95% of the daylit hours you have sunshine and intense sunlight at that. So we used the VE to run a bunch of different angles of inclination to come up with what was the optimal angle of inclination. And it came out that 29 degrees was what we ended up with for all of the south-facing shades and anything on the roof. And that's how we optimized that angle of inclination. The wind, well, as you can see, there isn't a lot of wind power available. We just don't have a consistent wind. The winds are primarily light and variable. Generally, the average wind speed is something like 6 miles an hour throughout the year. So we were, in fact, in favor of taking the wind turbines off. The college, however, wanted to keep them on just for educational purposes. So this is, after all, a science and technology classroom building. And they wanted to have wind turbines on to showcase this for the students. Unfortunately, the Department of the State Architect in California forced them off of the project because they were concerned that they may fly apart and harm passersby, even with light and variable winds. So they are not a part of the project any longer for that reason. Also, during both the competition phase and throughout the design phase, we used a bunch of different system types to optimize system selection. Some of these graphs are just high-level parametric, combining different strategies, looking at different HVAC systems, and you can see on the lower right the solution that we ended up with. It's a mixed-mode hybrid system where the windows are modeled as being available from 50 degrees Fahrenheit to about 75 degrees Fahrenheit, with some play for allowing for diversity. In other words, we're assuming that not everyone is going to be comfortable at the same temperature, so maybe 1/3 the windows will be open or 2/3 the windows will be open to allow for that diversity. There is also in here, there is also a mode where when it reaches a certain set point based on drywall, the HGA system, the VAV box, goes from closed in natural ventilation mode to open, and the window is closed. That's how it's modeled. In reality, it's based on a light system. So these windows aren't automatically operated. They are manually operated with a red light, green light, and there's also a purple light. The purple light is because there is a nearby harbor, the harbor of Long Beach, and from time to time they have a pollution event where they warn everyone to close their windows. So in that event, there is a purple light that will come on instructing the occupants to close the window. A red light would mean do not open the window now, or it's not a good time to open the window, and a green light would mean conditions are good for naturally ventilating. And also the higher occupied spaces, I should mention, it's required by Title 24 and indeed ASHRAE to have demand-controlled ventilation. So in the lecture halls, even if we're naturally ventilating and we don't have enough wind, which will, I'm sure, happen in this climate based on this climate data, the windows will close automatically based on a CO2 sensor reading and turn the VAV system on to provide enough ventilation to drop the CO2 level in the space. So as I said, this is one of the representative graphs of how we came up with balancing shading and daylighting and temperature control. This is one of the lab spaces, geology lab, and there is a couple of fume hoods in this space. You can see we're maintaining temperature constantly, a constant 72 degrees throughout this day, and this is just a representative day, but that temperature holds constant throughout the year. The drywall temperature you can see fluctuates slightly outside, and the solar gain peaks very much in the afternoon. The daylight illuminance does as well. But the idea here in the lighting gain you can see follows along. But the idea here was we ran this several different iterations with different shading elements on the outside, and we selected what was the best as far as minimizing solar gain and optimizing and not having such of a penalty on our daylight illuminance. So sort of in summary, we used the VE extensively on this project, both to win the project and then also to carry it through to design. And we are also doing another project for the same client. I'm in the middle. We just issued our 50% DD set about a month ago. I'm in the middle of using the VE as well on that project because we were very happy and pleased with the results and the modeling and the simplicity of communicating the results to the client. We're tracking for LEED Platinum, that's version 2.2. The models are showing a 44% reduction in energy consumption, and we're estimating a 50% reduction in energy cost. And the reason we're estimating a higher amount of cost reduction is because the rate structure is so demand charge dependent, and the demand charges are so driven by the hottest times of the year, which coincide with the sunniest times of the year. So with the PV system on the building, we're tremendously shaving the peak demand from the building or from the grid. We're also tracking for net zero, thanks in large part to the campus. Right now, the models are suggesting that about a third of the total power required for this whole building will come from the building integrated PV system, and the remainder will come from the campus system. We were very successful with integrating with Revit Architecture 2009, just a GBXML export. This was sort of a pilot project for us where we learned a lot about how to make that link work. And the SketchUp link with the VE was in, I believe, beta form when we started this, and we were able to use that for developing case study rooms. But with that, I think I can open it up to questions if there are any.
That was a great presentation, thanks. A question. How did the client respond to this information? Did they find it useful? Did they find it interesting, or were they oblivious to it?
They were very interested in the results. One of the big projects, if you're familiar at all with BIMStorm and the Enuma planning system, the college actually used that process, or the college district actually used that process to come up with their design criteria and their competition criteria. They were very engaged throughout, and especially the sustainability studies. However, one of the stumbling blocks, or one of the challenges we had, was there was a lack of familiarity with the VE. I mean, everyone in Southern California, and California in general, is familiar with programs like DO2, eQuest, Energy Pro, along those lines, but there was absolutely no familiarity with the VE. So I actually had to spend quite a bit of time making, as a colleague of mine likes to say, we're in the comfort business. We're not just about making people comfortable in buildings, but we're about making people feel comfortable with what we know. So I spent a lot of time comforting them and guiding them to show them that, yes, in fact, these studies were valid and that we could use the software. And once they got past that initial sort of questioning phase, they were very pleased with the results that we were able to send them, and they have been very pleased with what we've been doing with the VE and the reports that we've been generating.
That's great, Nathan. A follow-up question to that. You know, there's a number of other software that people would traditionally do in California. Do you think you'd have achieved the same level of savings if you'd used others?
Well, no. I mean, I'm familiar with Energy Pro. I used to do quite a bit of work in California for Title 24 compliance. And for those who aren't familiar, Energy Pro is a sort of a DO 2.2 based wizard, basically, that enables you to do Title 24 compliance. And when I say you, I mean pretty much any contractor off of the street can get the software and come up with a compliance. It has some very significant limitations, much like eQuest has some very significant limitations. They're even more so, more pronounced in Energy Pro. You can't, for example, model any sort of natural ventilation or operable windows. You can't do any sort of daylighting. You can do some controls for like occupancy sensors and that sort of thing on the lighting side, but there's no true daylighting tool in Energy Pro. So we still have to do an Energy Pro report to submit to the state because they do not accept anything other than Energy Pro and eQuest for Title 24 compliance. But we would not have been able to do certainly the natural ventilation that we did to this level of detail and integrating CO2 controllers to this level of detail with using either DO2 or Energy Pro. So and I'm a trace user, a trained trace user is what I sort of grew up with, or how I came to start modeling. and I couldn't use trace to do a lot of the studies that we wanted to do. And certainly the visual aspects, the graphic visualization for communicating, especially on these daylighting images here, on these daylighting images, are just tremendous. I mean, you can't, you know, when you talk about foot candle levels, and then you actually show them, I mean, we had our architects overlay actual rendered images with these data points as well, so that we could take and really communicate at a very effective level to the client what the differences and the benefits of doing daylighting and what the impacts of putting shading on the outside of the building was. You simply can't do that with numbers and graphs on a spreadsheet.
That's great, Nathan. Thanks a lot.
You sound like you had a fantastically engaged client with this, and you mentioned that they required BIM on the project. Is that something you're seeing a rise of?
Yeah, we're definitely seeing more and more clients become more and more interested in BIM. Particularly, I mean, Revit seems to be one of the more requested ones out there. It's certainly not exclusive, but everyone's asking about it. And we're an integrated architecture and engineering firm. And for us to be able to leverage our ability to have a Revit model and use the data from that Revit model as an analysis tool is a huge, I guess you could say, advantage for us, or something that we should definitely be leveraging more than a typical team of different pieces. I've worked in both as an MEP consultant and now as an integrated AE, and having that ability to take directly something that the architects have done and not repeat that work is a huge time saving. And it's something that, yes, both our clients are requesting, and something that we're really benefiting, or not benefiting, but trying to take advantage of as much as we can. So I would say that both the Revit side of things, as well as the interoperability piece with GBXML and other data exchangers like IFCs, are definitely something that an integrated AE firm such as us is becoming more and more interested in, and indeed clients are as well.
Thanks, Nathan. That's a really interesting overview.
Hi, Nathan. My name is John Gleason. I'd just like to ask a question on the very last point you made there, which was the use of the Revit model to translate across the building performance model. And I have two questions on that. The first is how you found the change in process to create that model to ensure the translation was successful, and how that procedure went for you guys, and was there much change in the process? And the second is, as you moved through to the building performance model, was it a case that it was the Revit model was translated at the beginning of the project and then two models were worked in tandem? Or was it a case that as the design progressed, the building performance model was constantly being updated from the Revit model?
Well, to answer your first question about process as far as the architects are concerned and how they actually construct a Revit model, there are some differences from how our architects would typically like to do things. Some of them were more cumbersome than others. And that led to the second part, leads to your second part of your question, where no, we didn't have one total model, one total big Revit model with everything in it. We did have one model that we would export to, and we would essentially, from time to time, usually once every 1 or 2 weeks, we would take the full model with all the bells, whistles, doorknobs, carpet types, all of that information in it, and we would just dumb it down, so to speak. We'd get everything down so all the wall thicknesses were the same. We try and line up windows on the center lines, that sort of thing. And we got to the point where we were getting pretty good with it, and then with this project, and everything stayed in Revit 2009, and we had it down to the point where I would say 90 to 95% of when we did a new export would come through properly, and then within Model It, I would just fix the remaining 5 to 10% in a few minutes to an hour at the most. Does that answer both of your questions?
Yeah, no, that's excellent, Nathan. Yeah, thanks very much for those, and also for the presentation, which is most informative.
You're welcome. My pleasure.